Now the N is going towards the center of rotation. I repeat again, N is going towards the center of rotation. Okay. So now if I were to write this out. Okay. So AB is the acceleration. ACC, I'm going to put it for point B. Okay, for point B. Then AA is the acceleration for point A. Okay. Then we have A, B over A, tangent. So this corresponds to the tangential acceleration. Okay, this corresponds to tangential acceleration of point B. Okay, of point B with respect to point A. Okay. So the magnitude will be equal to the magnitude. So A, BA, T will be equal to alpha R B from point A, where alpha is the angular acceleration. Okay. Then if we look at A, B over A, and then if it's the N down here, this is the normal acceleration of point B with respect to point A. Okay. So the magnitude will be equal to A, B, A, and this will be equal to omega squared B from point A. Okay. So if we were to rewrite the equation earlier, we can write it at this form. So A acceleration of point B is equal to acceleration of point A plus by alpha cross, okay, RB over A, okay, minus omega squared RB over A. So over here, as you can see, this is for the what? For the tangential acceleration. And this term over here, including the minus, is for the normal what? Acceleration. Okay, so the normal acceleration, why is it minus? Because it's pointing towards the what? Pointing towards the center. Are we clear? Yes. Normal acceleration is pointing towards the center of rotation. Omega squared RB over A, as in written earlier. It's the distance, relative distance, okay, B from point A. Now, the tangential acceleration, okay, the tangential acceleration, right? As you can see over here, right? You can see tangential acceleration when you are moving on a what? The straight line. Yeah. You can see the tangential acceleration on the straight line. Okay, so i.e. you only can feel the acceleration when you go straight. Okay. Keep going here. Yeah. We're going to do it done. Okay. Your hand Your strong hand is your right, so it's mine. Okay. So what we're going to do now, him and me, we're going to spin around the axis of the center, start spinning. So when we start spinning, what do you feel? Okay, so he's stronger than me, than you. We feel that we are going to throw what? Ourselves what? Upwards. That is due to the normal acceleration. And you all use an English word to describe it. Centrifugal force or centrifugal force. So be clear. Okay. It will only occur when you have what? You are going around a what? A curve, right? So when you accelerate your car in a straight line, you just go like this, right? When you make a turn, you tend to do what? You make a right turn, it tends to throw you what? Outwards. Are we clear? Okay. So over here you can see that the normal is always pointing towards the what? Center of rotation. Okay. Now, let's look at the solution procedure. Okay, let's look at the or analysis procedure. So the first thing we're going to do is we are going to, as usual, we are going to do velocity analysis first. So when we say we're going to carry out velocity analysis, we are basically going to apply VA is equal to VB plus by omega AB cross R A from point B. We're going to use this. Why we need to use this? Okay, because we have to what? Determine omega AB first, for example. Okay. After you've done your velocity analysis, okay, we are then going to carry out you're going to do your kinematics. Okay, we're going to draw your kinematics diagram. So on your kinematics diagram, okay, we know that acceleration of point A will be equal to acceleration at point A in a tangential direction plus by acceleration at point A in the normal direction. Likewise, you know acceleration at point B is equal to acceleration at point B in the tangential direction plus by point B in the normal direction. So both of them, you have to determine the direction. Yes. Yeah, this is just a general formula. Later on, we just put minus. Yes. It does. I'll write the next formula. The kinetic diagram over here means this is a vector form, right? Both of them has vector form. Vector form as in point A have both what? Point A have both normal and tangential. Normal and tangential. Point B also has its what? Normal and tangential. Now, this is only true, okay? This is only true. Okay, so this is only true for general, we call it general motion. This is only true for, wait, this is only true for relative for not relative motion. What the diagram, what did the diagram say? This is only true for general plane motion. Okay, general plane motion. General plane motion means we have both what? Linear and what? Rotation. However, okay, for linear motion only, I highlight down here linear motion down. So let's say if both have linear motion only, so AA is equal to AA tangential, AB is equal to AB tangential for linear motion only. And finally, as what you were saying, we're going to apply the acceleration equation, which define, okay, A of point B is equal to A of point A plus by alpha RB A minus omega squared, okay, RB from point A. Now over here it's not a cross, it's just a simple what? Multiplication. So if I were to expand this equation over here, what you will have is this, okay? So it's AB tangential plus by AB normal. This will be equal to AB, AA tangential plus by AA normal plus by alpha RB over A minus by omega squared. Wait, omega squared RB over A. Now I want to pay attention to the formula. You want to pay attention to the formula. Okay, where you have AN. Okay, the normal AN we know that is also equal to omega squared R. Right? So note that V is also equal to what? R omega. So from here, we also know that omega is also equal to V over R. So therefore, AN is equal to V squared over R squared multiplied by R, and it can be also equal to V squared over R. Yes. How long did you put up your hand? Next time just say, excuse me, you know, don't let me finish and then yes. Oh, you caught me there. Cross. Thank you. Going too fast. You drink alcohol, yes? No, okay. If not, you'll be so drunk. Thank you for telling me. I really appreciate a lot. Okay, I buy you plenty of orange juice. Okay. Right. This is cross over here. Thank you. Okay. Okay. So we are going to look at, I don't do easy examples. Let's look at one of the examples now. Okay. I don't know whether do I have the time, but let's start. Okay. Okay. Now this example, I want you to focus on this example. I repeat again, I want you to focus on this example. I'm not saying that it's going to come out, but I want you to focus. Okay. So this is the question. Okay. By the way, I forgot to write here. This equation is only suitable for 2 points within a rigid body. Are we clear? Okay. It will not work if it's not a rigid body. Okay. So I want to look at this problem over here. Hey, come on. Given at an instant, the gear have the velocity and acceleration shown. Determine the acceleration of point B. Okay, we are going to find what is the acceleration at point B. I have deliberately post the solution manual deliberately. Okay, so what you see over here is what you get in the solution manual. And pardon my French, is like holy shit, yes or no? Right? Tomorrow, I'm going to solve this, that it's not going to be holy shit. It's going to be so easy, and you say, is that it? Okay? By applying the principle of rigid body. If that's the case, welcome to Jamaica. Have fun.